Sure. Okay.
Okay, about the PMI itself. PMI is like worldwide tobacco company, that's true. But company which take a risk and have a vision to have a smoke-free future. Means we are trying to change and we are trying to adjust to the changing environment. So like people switch from classic mobile phones from Nokia to iPhones or Androids. We are introduced new products, reduced risk products, which are like not smoking. We are like 𝐾𝐞𝐤𝐿 right now, and we are doing modern products. This is company vision. And about IT, we are also changing. So as I said, our like objective strategy is like public cloud first. However, you cannot deploy private cloud everywhere. So what we are also checking on what is available on the market. I will tell you in a few months about the number of people in PMI, more than 300 IT experts in IT Hub. Aleja Jana Pawła II 196, like 71,000 employees in total around the world, and I think most of the important locations. And only in Krakow we have 20 different nationalities in IT Hub, and 33% of the position held by women. So I think quite interesting. Even more, I think, not than 9 departments: artificial intelligence, big data, platform engineering, cloud operations, design thinking, UX, lean, startup, and we are doing agile. We are trying to modernize our IT and change from standard solution to modern ones. And about the shortly about the history, I already presented this slide, but I'm like trying to repeat it in every presentation to give you the background, how we started and where we are. So we are just speaking about the cloud. As you can see on the slide, we started, of course, like every company, on premise, and then we like switched from some services, mainly web applications or internet-facing applications, to public cloud, but on the small scale. And we thought what we should do with our on-premise hardware, how to manage in a better way. Then we decided to deploy solution supported by VMware. We called it SDI, software-defined infrastructure. That's on the VMware solution and VMware suite. But then we had like huge organizational change of the CTO, and totally new vision, no strategy. So public cloud first, migrate each and every application to public cloud, and please do it in 2 years, because this is our objective, because we are shutting down our 2 main data centers in OC in Switzerland, and we are doing this actually. So there's like a strict deadline, end of the year. We are closing the data center. Is already sold, so we need to move out. So there is no other options. Of course, we are still keeping the local infrastructure in the factory sites. So our vision is to have like factory sites still equipped with the hardware, because it requires either low latency or high availability, and like, or sometimes low regulation, and equip our like all location like offices or like the sales department with serverless. Yeah, so all services delivered from the public cloud. And here's also our vision. So as you see somewhere, there is a hybrid cloud. What we were testing different solutions. So yeah, VMware based is the one of, and the second is Outpost. What is Outpost?
Yes, so maybe let's go back to the previous slide, because I want to show you one of the important point. when we realized that we need to keep the server infrastructure in the factories because of the, as Piotr said, latency reasons or data gravity, data locality requirements, we were like, okay, we'll keep it on our private cloud, on our SDI. But then it was around 2019. But if you remember, if you are aware, at the re:Invent 2019, AWS Outpost was introduced service, and our AWS partners contacted us and said, guys, maybe you want to try it out. Maybe you want to you are able to run your workloads for factories on using that service. So
sounds interesting.
Yes, it caught our eye because what you can read in this description, that it's a fully managed service that offers the same AWS infrastructure, services, APIs, and tools, and you can run these services on-premise facilities for a truly consistent hybrid experience. Okay, that's a mouthful. But as I said, this caught our attention, caught our eye, yeah. And when we learned about the Outpost, we could see, okay, some of the benefits of that service. You have the same service infrastructure as in AWS or in regions. You have the same management platform, APIs, tools. You have the same skill sets required to manage that infrastructure, and it's a fully managed service. So you focus on building your differentiating applications for business. Yes, but we are also told that there are some limitations. That like not every service that you know of that is offered in AWS can be run locally on Outpost. When you think about it, it's reasonable. I mean, I don't know, you cannot run Route 53 locally, for example. Yeah, okay. And one important thing that we also got a warning that AWS Outpost was not designed to run totally independent from the without the internet connection from the region. Yeah. So this point is important because it will relate to it later on. You will see. So what kind of the services you can run locally on Outpost? EC2, EBS, ECS, EKS, RDS, EMR, ELB, and S3.
Sorry for interrupting. So for those who are not like really familiar with all the namings, you can start the virtual machine. You can have containers. You can have a storage. You can have like database either on the server or like as a managed service. You have like some load balancers, and purely you have a storage and other services.
Yes, and when we look at what we might need to run this to run our workloads on Outpost, we could see that okay, we have all the puzzles that we might need over there. Okay, so that's why we got interested in this offer. So we decided to run a POC, proof of concept, of Outposts in our factory in Krakow, with the main purpose to check the feasibility of using that service as a replacement for existing server infrastructure in PMI factories. This is also important point because our expectation was that we will be able to replace all the bare metal, all the servers that we have
production stop, we are simply losing money. Yeah,
yeah, exactly. And so our applications are built to use these two server rooms to be fault tolerant or at least highly available. So our expectation was that with AWS Outposts, we'll be able to also have this high availability, at least for these applications. Yes. The other point that we wanted to check is, are we able, because we were told that AWS Outposts have some independent. It's not, as I said, it's not designed to run totally in a disconnected mode. Our expectation, we wanted to check if and for how long are we able to run this. The workloads can continue to work. So in an event of losing the internet connection, we don't actually stop the production. Yeah.
Yeah. So what we were like informed, it was like, okay, if you lose your connection to the internet, to the region, the Outpost should operate, but you will not be able to apply any changes. You will not have access to the console. This we can somehow accept, yes, as long as the workload is running, the production is running, we can survive maybe 1, 2, 3 hours, or even one day without until we fix the connectivity, which is always also redundant. But yeah, we didn't expect few things which we'll like share in the moment. Yeah. But before we will go to this stage of the application testings and what we found out, we would like to share what is required to have Outpost installed in your location, in your factory. Right now there are like different appliances, so you can order the whole rack, or you can order 1 or 2 U of Outposts. When we were like ordering it, it was like only available in the full rack, and there is a lot of prerequisites which you need to fulfill before the Outpost will be delivered by AWS and installed in your location. So as you can see on the slide, maybe it's not like colorful and nice tightly. The whole process took a few months to actually order the hardware and prepare our infrastructure, our server rooms to install it. It's not that, okay, it's standard. We have a lot of servers from HP or Dell, and okay, one more Outpost is nothing. Yeah? We have electricity, we have air condition, everything is there. So why just not install it? No, there is like special requirements from AWS to install Outpost.
Yes, and I would like to you to pay the attention that what we are talking about took place in 2020. Yes, so 2 years ago. Since then, the service itself evolved. So please take what we tell you with a bit of, okay, we will point out what changed during that time on the Outpost. Yes, but we are sharing our experience of our POC that took place like 2 years ago. Okay, this slide is like directly from AWS, so it looks nicer maybe. But first, you have like pre-sales meeting, so you need to define your needs, what exactly you are expecting from the Outpost, what kind of workload you would to run on it, and how many virtual machines you would like to install there, how many databases, how big the storage should be. And basically when you are like designing Outposts, you have like 20 something options, or maybe even more right now. You are also like deciding what kind of EC2 machines you would like to run on it. So it's like design based on your requirements. So when we were like deciding what kind of workload we'd like to deploy, we also had to pick up type of the machines. So maybe Miłosz, a few words. Yes, as it was a POC, so we estimated that we're gonna go with the general purpose like a M5 family at the time. So we ordered two. So we ordered a rack with two M5 24X large. Yeah, we'll show the details in a moment. And just 11 terabytes of the EBS volume storage.
you are starting the standard ordering process, like in AWS for new account, maybe a little bit like extended. And then quite important part, before you start the ordering process, you need to create new AWS account, because Outpost will belong to you, one of your AWS account, and also VPC, which will be used on the Outpost, will belong to this AWS account. So it's like extension of the regional VPC to your Outpost. That's about network also on the second slides. About the site validation, quite important. So when you are saying that you fulfill all the requirements, and there are like requirements are sometimes pretty tricky, the engineers are coming from AWS and doing the site visit and saying that, yeah, it's okay or it's not okay. Yeah? So you can proceed with the order or not. If everything is ready, there is like order approval and service delivery. But if during the service delivery, the Outpost will arrive to your location, to your site, and secure that something is not working, or you said it's ready, but it is not, they will not leave the Outpost on site and wait until you will fix it. Yeah? There will be simply a rollout. They will take everything, and you will need to wait for a next installation when you fulfill all the requirements.
Yes, so it's pretty important to prepare for the installation properly to avoid any mistakes, because as Piotr said, for the security reasons, they cannot leave the rack in your server room for the next day to continue the installation on the next day. It's either they deploy it, it's connected and manageable from the console, or they take it back.
Yeah, and the next step is, of course, when this delivery installation is done also by AWS engineers, and then activation in your account to start using it. About the timelines, it's taking weeks, so it's not like you are ordering one day and next day you have Outpost. It's taking weeks. In our case, it took 3 months or even more to deliver it.
Yes, around 3 months, 2-3 months. Okay, and so now for the hardware geeks, how does the Outpost look like? In our case, as we said, we ordered a rack. Okay, it's a 42U rack, inside of which you have some network switches, the compute servers, the compute units of the ordered SKUs, some storage, and power bar and power distribution unit that goes over there. So you have a basically a rack, and you connect it to the power, and you uplink it to your local network. Yeah. So we ordered two this kind of racks, one for each server room that we have. And it's worth noting that these racks are pretty heavy, and they are kind of one piece. It's a one-piece hardware, so it cannot be when they roll in the rack. It cannot be. It's not assembled. It's not a rack assembled in your server room. It's something that they need to roll into your server room, which
deliver
might be
in one piece, yeah, and
yes.
Quite heavy piece.
Yes, and which makes very important to check beforehand if you have proper clearance on the path from your unloading bay to your server rooms, which in our case was causing some problems. And
in the past we installed a lot of servers in our server rooms. Never had an issue with Outpost. We had, we managed, but it was like pretty difficult. And if you notice, there's like small information, seismic bracing. Never had such requirement in Poland, yeah, for non-single server room I ever supported. For Outpost, there is. So you need to have it in place, and we already, when we were like dealing with this, we had to like order it, and there was pretty hard to find a company which will build it for us. It's not like really complex, but not standard in Poland, yeah.
Well, yeah, it wasn't complicated, but it was surprising that we need to install such a structure, yeah, to put it in our server room. Okay.
Yeah, then there was electricity, which is pretty standard, and then requirements about the connection to the internet, minimum 100 megs, preferred 1 gig, but it's like other topics, and network design, yeah, quite interesting. Yeah, so as mentioned, we installed 1 rack in each computer room. Each rack was connected to the local distribution switches in our cases. And we also had each rack was cross-connected to the other server room for the redundancy purposes. Please take a note that these racks are not interconnected with each other directly. Each outpost is treated as a single and separate unit. So they talk with each other, but it goes through your core network, through your backbone network. Yes. For outpost connectivity, there are two types of the networks or connectivity types. One is the connection with your local network, which is managed by a local gateway. It's called local gateway connection. And the second one is a service link that is a connection with AWS region, where the outpost is connected to, yeah. And in our case, we manage that by having a separate VLANs for those purposes, which were utilizing the same uplinks. Yeah. Yeah, so you have like different options to connect outpost to the region. You can use like VPN, you can use direct connect. In our case, it was like mix. So we went through our like local connection between company sites, and then from our main company site we went with direct connect to the region in Ireland. And it was like working pretty stable, no issue related to the connection on like site availability and outpost availability. Also, AWS at that point required to have at least 1 gigabit internet connectivity. I think that recently they reduced that to 500 megs. So that's also worth noting, that you need to have a proper internet connection link on your site. Yes. And as Piotr said, basically the outpost is using the same VPC that you have in region, and it's treated. It's connected to your when you create the outpost, you select to which availability zone it belongs to, and this is also important from the availability perspective, because you can imagine that when that particular availability zone is not available, then your outpost is also you cannot manage your outpost. Yeah. That's why we also decided to have two racks. But yeah, having two and different availability zone and different VPC is more complex than we expected. Okay, so once we had the outpost installed, connected, we confirmed that it's operational from AWS perspective. We started to deploy our applications for factory, and this is also important to realize that our aim was to use Outpost. I'm going to repeat it as our main platform to run the workloads that support our factory floor, to run the production, to run the applications that support the production, manufacturing processes in the local factory. Okay, and at this point, we pre-selected some of the applications. You can see that we selected 3 legacy, how we call it, monolithic. There were kind of 2 and 3 tiers applications. One of them was warehouse management system. The other one was track and trace application. And the third one was kind of a process control application. So we wanted to test
each type of the application that we have in the factories. And also we had one kind of modern message bus type of application deployed, which was using the more modern architecture, which was using the EKS and 𝐿ę𝐝𝐻. So because we decided to do it like that because as it was mentioned in the previous slide, we wanted to ensure that we can run existing applications that we currently have on the production floor and the new ones that are coming. If Outpost can allow us to build our cloud native.
If you are looking on the production floor, the machines are there since, I don't know, 10, 20 years, and they will not change really fast. Maybe the software, which is supporting the production process, is changing, and you're adding new features and new maybe IoT devices to monitor the production or to improve it. But it's already there, so you need to deal with what is there, and with the software, which was also maybe built 1 or 2 or 3 or 5 years ago, and it will not change immediately in next 1 or 2 or 3 years, because it's simply return on the investment, and it's so complex to support the production that it cannot be changed from one day to another. So we have a lot of monolith applications, surprisingly Microsoft SQL based, which we would like to move to this Outpost. And of course the modern application based on the container services, so Elastic Container Services, which we would like to test and run in the future more similar applications, which we are developing right now in PMI.
Yes, as Piotr mentioned, our legacy applications are mostly using the Microsoft SQL Server, and we aimed to utilize the RDS on Outpost because, as you remember, it's available to run it on Outpost, but we discovered that there are some limitations of that service. One of them was that Microsoft SQL Server database engine was not available on that time.
That time there was no Microsoft SQL on the RDS, even if it was available in the region, but not supported on Outpost.
Yes, actually it was not available. And the second thing is that even if we had some kind of different database engine that we could use RDS for, there was no multi-AZ deployment available. So you would need to do some other stuff.
Tips and tricks, yes.
Yes, to compensate that. That's why we decided to do it old-fashioned way. So we deployed EC2 instances and basically created a shared Microsoft SQL farm using my failover cluster and storage spaces direct. Thanks to that, we got our desired database
fulfill our requirements related to high availability and some kind of disaster recovery, but in the same time you need to remember that you are stick to one availability zone and one VPC. So you are losing this redundancy on the region level. However, it was one way or another. No other option.
Okay, and a part of the applications, we also wanted to test, to run some infrastructure tests, and basically we tested it against 2 scenarios. One was unavailability of single Outpost track. So basically we disconnected single Outpost from the network. We simulated it by disconnecting single Outpost from the network. And we tested if our applications were able to successfully fail over. So it was more, and if we are still able to manage the second Outpost, okay. So this test went fine, and the second second scenario was we wanted to see how long are we able to run the work
disconnected mode. So you are losing internet connection, you're losing connectivity to the region, and you would like to survive with your production. Yeah?
Yes, and for some workloads, we were able to run for these legacy applications. We found that surprisingly we were able to run for over a week these workloads without the internet, without this connection to the AWS region. But on one particular application, actually the one that was using EKS, we found out that
so the mother one, which you would like to use cloud for.
Yes. So we found out that the master nodes for EKS are in fact running in region. So with this event of its connection, they basically see the nodes, the worker nodes, as unhealthy, and they terminated them upon reconnection, which at the time led to the data loss, because that's how the application was designed. So that was kind of a surprising discovery.
So in the nutshell, you have like your workload running on the Outpost, delivering the services to the factory, but your managed node is still in the region. So losing the connectivity, you are losing all the pods.
Yes, but I want to have a note here, because I heard, I still need to confirm it, that this actually has been corrected. AWS made some progress on that, and don't quote me on that, but I heard that they are preparing that the master nodes will be running locally also.
But it's still not GA, so not general.
Yes. Okay, and as a result of this test, we find that not only the number of the services that you can run locally on Outpost is limited, but we also discovered that the services that are available on Outpost have some limitations as well. Like EC2, okay, this one is pretty obvious. You have only the instance types available that for which of the type that you have hardware installed in your rack. Yeah, okay, this is kind of obvious. But the other one was not so obvious, that when you have a compute capacity, defined total compute capacity, and you need to decide how you're gonna partition these instances, this capacity into number of instance sizes of the T-shirt sizes. Yes.
So how many instances you can run on it?
Yes.
You need to predefine this.
Yeah. This can be adjusted, but yeah, to some extent. So yeah, and of course you cannot have like more.
So you don't have this flexibility which you have in the region cloud when you are okay. I would like to change this type of the instance to the bigger one or to the smaller one because it's no longer like needed. Or we'll put a bigger workload and we need like 2 big instances instead of 4 small. No, it's not working that way. You need to define the T-shirt sizes, and it's like maybe not fixed. Redesigning it, like you need to destroy your environment. Yes,
kind of. Yes. For the EBS, we had a you have only GP2 and GP3 capacity, if I'm not mistaken, unless you order other types of the SKUs installed. For ECS, okay, this service we haven't tested during the POC. Okay, for EKS, for Elastic Kubernetes Service, we found out that it requires minimum 2 subnets in different AZs. Okay, okay, it's a well-known requirement. But Outpost is your single Outpost is in a single AZ. So you
deploy this. We work like for 2 weeks with the AWS engineers. They do some like workaround and tricks and deploy manually the scripts on the Outpost. Finally, after like 2 weeks, well, to like run the workload on the EKS, and it started to operating, but it was like pretty difficult because of the like standard limitations. So you have something out of the box, but it's not working.
Also mentioned the fact that the master nodes were running in the region. So this we already discussed. And well, we had the Outpost deployed with 2 different VPCs. Each Outpost had their own VPC, and the targets for EKS needs to be in a single VPC. So we couldn't stretch the EKS cluster into two different outposts, into two different VPCs. So we had a kind of a single point of failure. We were able to deploy the cluster on a single outpost with a single VPC. Okay. We also applied some workaround at some point, but it was kind of a surprising finding, yeah. Okay, which we discovered. For RDS, we already mentioned that at that time there was only MySQL and PostgreSQL database engine supported, but we know that Microsoft SQL is available now on Outpost. And we also discussed that there was no multi-AZ for RDS. Now it's possible for MySQL and PostgreSQL. It's not available for Microsoft yet. EMR we haven't tested. For ELB, for Elastic Load Balancer, we found out that you can have targets only in a single subnet. So we are not able to have a cross-server room high availability for some of our applications. And for S3, okay, this service was actually introduced during our POC. At the beginning, it was not available. It was introduced on Outpost during the POC, and we are not able to test it. And
but
the last
maybe comment for this. Here I have like positive feedback because they introduced this S3 service during our POC test, and they said if you would like to test it, okay, we'll like shorten the time. But if you would like to test, we can simply enable it because the storage is there, yeah. Mm-hmm. So we already deliver it because we predicted that we will deliver the service soon, and we just need to enable it. If you would like to test, of course, you need to pay for it.
Yes. And the last limitation that we discovered was that, despite of the fact that we had a 10 gigabit connectivity from the outposts to our local network and between our server rooms, we were not able to get more than 5 gigabit per second bandwidth or respective throughput between the workloads that were running on the outposts. And it wasn't caused by any bottlenecks on our infrastructure. We investigated that with AWS, and we were said that there is a limitation when the VPC leaves when the traffic leaves the VPC on Outpost through the local gateway. There is such a limitation. So for us at that point of the time, it wasn't a big issue, but you can imagine that for some workloads, it might be. Yeah.
And then our conclusion. Yeah. So as you heard, we didn't met all expectations which we set. I mean, we didn't met our goals. So partially, yeah, the simplification and consolidation of the infrastructure landscape in PMI, yes, you can. As you have the similar services, you can have one team which is like supporting public cloud services in AWS, and at the same time managing the Outpost services, knowing that there are like some limitations. The last one, providing the platform to build, deploy modern cloud-native application for manufacturing, yes, but also with some limitations. And the others. Yeah,
were kind of they were met partially. Yes, we see that high availability across computer rooms requires some additional work because or applying some workarounds or tricks because for even this mentioned RDS multi-AZ was not available at the time. We could see that the services and applications are able to continue to work. In some cases, when you are disconnected from AWS, when the Outpost is disconnected from AWS. And basically, we were able to run existing legacy manufacturing applications without the need of redoing their architectures. But as I said, it it required some additional work on our side and applying some kind of crazy stuff, and which led to the what we built was not optimal at any.
So it's not like easy way to just move, lift and shift the application from on-premise to Outpost, and it will work without any like adjustments. Yes.
Yeah, exactly.
So what we decide, we are not saying that Outpost is like bad solution, not at all. It's just our requirements are quite specific, especially if we are speaking about the production environment. If you just would like to have a solution when you have part of the public cloud in your private server room to address the issue related to latency and availability on the services on site, I think is like pretty great, because you don't need to learn new things like with VMware or install old stuff, and you can manage in the same way. So for such purposes is great, but as it didn't fulfill our requirements, we decided to end the POC. We are not saying we will not redo the POC in the future, because this is also the quite fresh service. Like presented 2 years ago, we immediately decided to test it. And even during the POC, as you saw, there are like new services coming and being enabled on the Outpost appliance, which you just need to enable, and it's there and it's working. Or they are doing this small modification from the software side, and it's there, So it's constantly like they are constantly adding new features, and they are listening the customers and their needs. So from this perspective, I cannot complain. However, on that time and that stage, we didn't decide to proceed with any production deployment because of the risk and the complexity. But we are like doing the follow-ups, and we are looking for the future of the Outpost as a possible scenario for our hybrid solutions.
Yeah, because I want to add one thing. You must remember that our expectation and the purpose was that we will replace, or we will roll every server out and put the Outpost in the factories, and we are expecting that we are able to run every type of the application that we have, and we have many of them that supports the production floor on Outpost easily. And I can imagine that situation that we can use Outpost as a additional infrastructure that we can have in the server room. Okay, you can create. Are you crazy to you want to add even more complexity to the factories? No, but that would I can imagine a situation that for a specific application we could use that platform where we have a specific needs as additional. But
for now, we cannot replace simply our old private cloud or private infrastructure with Outpost.
Another thing is that there's work to be done. If we ever consider using the Outpost again, there's work to be done on AWS side and also on the PMI side. On AWS, yes, we passed the message. Okay, we expect this to be fixed, or this to be improved, or changed. But also we must consider when we build new applications for the factories. We must consider, and we have an ambition to deploy them on Outpost. This must be taken into consideration that you design your application for the Outpost, which is not something obvious, because you might think, okay, my application can run on AWS, but can it run on Outpost? You need to ask yourself with these limitations in mind. Yeah. Okay.
So, questions.
Ooh, questions. Cool.
Yeah.
I didn't even say that. There are going to be awards for the most active people. Question and answer.
Hi guys, thanks. So one question, because you mentioned that with Outpost you need to pay upfront for the capacity, right? So you just order in advance some capacity, right? Or
you have three options. You can pay as you go, so without any upfront costs.
But what do you get then? I mean, how big is the RAG? What is an option that
you are picking? You need to decide from the options available in the, I would say, in the shop, in the AWS shop, what kind of appliance would like to pick up, and then based on this you are receiving the price, and then you need to decide how you would like to pay for it.
Yeah. So you have no upfront, so you pay as you go. And the second thing is you have a 1 year commitment, if I'm not mistaken,
3 year
where you get some discount, and then there is a 3 years commitment, and 3 years commitment and 3 years upfront cost.
Yes.
Okay, and comparing to the public cloud costs.
And on-prem?
Maybe a tricky question.
If you are like calculating the cost and the price of the outpost, you need to consider not only the price of the outpost itself, but the additional things. So if you will have if we will manage to replace our classic infrastructure with outpost, you can have a single team, or maybe not single team, but people which are trained only and have skills related to AWS or public cloud services, and in the same time they can manage Outposts. So you don't need to have a separate team supporting different infrastructure like VMware or classic VMs. You have single vendor to manage, so it's also reducing the costs. And the hardware is simply deliver for you, and you don't care if it's failed. They need to either send you the parts or replace it. Yes.
You just need to manage the capacity.
Platform as a service.
Yes, it's a platform as a service, more or less. Okay.
So maybe one more last question from me. Okay, because maybe I missed it during your presentation, but about this network latency and conditions. So comparing to our private cloud solution and versus Outpost versus public cloud in some.
There was no difference if you had a virtual machine, for example, running on Outpost, and you had our bare metal server even. We haven't noticed, or at least it was not in the range. It was not visible for us.
Okay. Thank you very much, guys.
Any other question? Okay, cool.
Thanks for the presentation. So it has been stated a few times that you can manage this on-prem extension the same way from the hyperscaler perspective. Yes. So have you some experience with the infra as a code management in this context? I mean, CloudFormation, Terraform.
Yeah, so we deploy
any limitations.
Deploy most of the infrastructure there based on the CloudFormation, especially the modern ones. Yeah, at that time we decided to use a CloudFormation, for example, to deploy EKS, and it works without any issue. The same like in region. So in this context, there's no difference.
So the only difference is that you need to have internet connectivity to achieve that. Yeah. Okay.
But imagine from our experience from the past, it may be the issue. It's right now maybe really rare that it's happened, but it may happen. Yeah.
You said you used some workarounds in certain areas, and my question is, were there some issues or problems that you were not able to fix and had to live with that? So something that is...
few. One I think mentioned that was related to the EKS deployments, which was a nightmare for a few weeks for us, because we really would like to run this modern, from our perspective, containerized application on Outpost to prove that it is working there, as this is public cloud in your private location. But to make it happen, it's it took, as I said, a few weeks. Then we had to apply some workarounds delivered by AWS itself. So run additional scripts on Outpost and execute it to make it happen. I hope that they fix it already, so it's like it's there. But then was the additional limitation related to the availability zones.
Yeah, I want to also add that AWS support was very helpful during the POC. Even when we gave up with some issue, they were pushing, they were going down the rabbit hole and finding some solutions or workarounds.
Yeah, the few we didn't solve, like this cluster of the SQL. So yeah, we simply need to accept that it's working that way, and we cannot deploy it in different way. And also the availability of the services. So we tested few services which were not GA, not general available. It was like AWS goodwill that, okay, they shared with us, you are running the POC, we can share with you what is like already as a, from our side, even proof of concept, you can test it, it's up to you, but please do not run any production systems on it. That was fine for us because we just test this, but it also like was the decision that time that we will not go with any production workload. Yeah.
Okay, we have also a few questions on YouTube. So the first question is from Dominic. How many outages for partial have you had during the POC?
So by like external, I would say, situations, so like internet connectivity drops or similar cases, I think none, zero. So and also Outposts were like up and running all the time.
No failure, like hardware failure or anything like that?
Nothing.
Well, there was one, but I think there was one when we were already concluded the POC and we were waiting to return the Outpost. I remember that one of the disks failed in the one of the rack, and we didn't notice that. The AWS support guy came in to
replace it. Yeah, but you need to be aware that the Outpost is built in the same way AWS is building their infrastructure in the regions in their server. So it's like almost copy-paste solution. So it's really like from the hardware perspective, it's really well designed and well tested. And as Miłoszz said, if it's failed on one disk is failing, you will not notice, yeah? Because everything there from the hardware perspective is redundant.
Okay, thanks. So a few more questions. One from Fabio. What is this anti-seismic platform? How does it differ from the technical service floor in data center?
Well, the one that we had installed in Krakow server room was pretty simple or primitive one. Basically, it was kind of a metal plate on which or maybe kind of a metal plate that was bolted to the elevated floor that we have. But also it was not bolted to the elevated floor, but to the actual floor, the epoxy floor that we had in the server room. So that the seismic bracing that we had, it was like kind of a cheap version of it. Maybe because we are not in a seismic active zone, yeah. So there was kind of
like minimum requirements to have this like plate and install Outpost on this plate. So you cannot just install it on the standard technical floor, yeah. That was the prerequisite, and they said that what we did is enough for our area, means our location perspective. It's what was probably in more seismic area, the requirement will be higher, yeah.
Yeah. Okay, I get it. Thanks. Another one from Fabio as well. How did you monitor infra while disconnected from the internet? I suppose that CloudWatch logs or events and alerts was not available either. So how it's monitored?
Well, frankly speaking, we didn't. When we ran this infrastructure test, we just noticed that we are not able. Of course, we are not able to manage the racks. The EC2 instances were like, I don't know, the status of them were unavailable or something like that. And in a matter of few hours, we were contacted by AWS support. Okay, guys, you have some problem. Even though that we told them that, okay, we're gonna run some tests, but yeah, they were responsive to that event. And for our workload infrastructure, no, we didn't.
Yeah, at that time there was no tools provided by AWS to monitor it from the perspective. Is it disconnected? They can see that it's disconnected. The resource is not available from the region perspective. We can see it in the console that it's not available. But that's it, yeah. All the if you have predefined alarms, CloudWatch events, it will not trigger anything else that is not available, yeah.
Yeah. So the only option would be to have something outside of AWS to monitoring
yes,
the applications.
As Miłosz said, even if we inform them, we raise the case that will proceed with the test, we immediately have a contact from AWS. Hello, you have issue with the connectivity, yeah?
Okay, great. The last question I can see is any degradation in performance during the POC and any workaround?
So there was no performance degradation comparing to the workload you can put in the region, or as Miłosz said, similar workload we had on our standard virtual machines running either on Hyper-V on VMware. So it was transparent for us, yeah, from the performance perspective.
Okay, and one more comment. We didn't have a goal to test the performance of the Outpost. We didn't run production workloads on it. We didn't simulate any workloads. But from the numbers that we saw, during our tests, we could see that it was performing okay, yeah. So we didn't expect to have, maybe except of that 5 gigabit per second bandwidth between the VPCs, between the outposts. Okay, that could potentially have some issues if we had deployed production workloads, especially that we for the SQL farm that we deployed using storage space direct, because it's with the storage space direct, you have a kind of there is a storage traffic that needs to synchronize between the racks. Yeah, so I know that it can utilize as much as of the bandwidth as you have. The more bandwidth you have, the better synchronization you get. So this 5 gigabit per second could potentially be a bottleneck.
Okay. Here, thanks for the presentation. I have the question, do you think that you tried this service too early? Maybe in 3 years, if you try it, you would see a more mature application or service and the result would be different?
Yes, it's not that we tried too early. It was proposed by the vendor, by AWS, to test it. And they also have an expectation that it will fulfill our needs. Because what we discuss, what we present, what we would like to do, and based on the service that time available in the Outpost, it's on the paper looks pretty good, yeah, promising. We accept some limitations, and we know that we will need to deal with these limitations. But okay, let's accept, let's test, and so on. Then there was constant discussion between us and AWS, what we can improve and how fast we can improve. So they were trying to convince us, okay, please do not close this POC, please do not remove your Outpost. We'll deliver in the next 3 months additional features. Maybe it will fulfill your requirements. But running the hardware in your server room, which is not used for the production, and paying for this is better. The commission, wait maybe 1 or 2 years when it will be mature enough and you have all the services which you need, and then you can retest again. Yeah.
Okay, I have different opinion. Maybe we run it too early, but it wasn't. It was a good lesson for AWS, I would say, also, and for us. Now we have some experience about the AWS Outpost. We see it potentially that we can potentially use it in the future. We know about the work that we need to do in order to utilize that service. And also AWS knows what we expect from them to deliver, to how to shape that product. I'm not saying that they're gonna fulfill all 100% of requirements, because for some, from what I know on how they are building that product, it's gonna be very difficult. But it's, you know, you can meet in the middle, yeah.
Okay.
I have a question related to this last question. So what do you think? It was worth to test it then?
Definitely. First, you have the skills in place. So it wasn't like, okay, we would like to deploy Outposts, and first we need to learn what is AWS, learn all the services. No, we had the people with knowledge about the AWS services in place, and we can simply. And the second thing, we had like experienced engineers dealing with our on-premise infrastructure and have a know-how about the requirements coming from the production and know-how about the connectivity which we need in place. So from this perspective, not at all. And it's like also good like experience and outcome from this, how you should design the future application to run it in, for example, on similar solution like Outpost in the future. Yeah, you need to think about this, and without this POC, I think we will not figure out. So it's not so obvious. Yeah.
Okay. Because I heard of all of this beautiful story. It's very interesting. I can say, and I just noticed that there were many teams involved into this POC, and also it consumed a lot of time and effort of different people. And now what we know that, okay, we will maybe use this in some time, but as Miłosz said, it's difficult because AWS is going some way, maybe not meeting our expectations.
Okay, but I think this is also the goal of modern way of management IT and IT process. You are taking the risk, you are accepting the risk, and you accept you may fail. Yeah, if you will not take the risk, you will always be stick to one solution which is like up and running, and you will not would like to change. So it's like with our products. So we can say, okay, conventional cigarettes are great, they are selling, and let's stick with this and stay forever. Yeah. Then our customer will say, okay, but we are no longer interested in these conventional products. Yeah. So on some stage, you need to take a risk and test and develop. And the same with other applications. Probably SAP will never move to the SAP HANA if they will not take the risk and experiment. Yeah. So like many other solutions, and also firewall settings and so on. You need to, on some stage, take a risk. If you have the resources, invest these resources. If you do success, great. If not, it's like lesson learned, yeah, for other options.
Thank you.
Thank you very much. Okay, I just read from internet. Okay, so Ratandeep Sharma, between AWS Outpost and Azure Stack, which you recommend?
For Azure Stack, we haven't tested.
Good answer.
Yet.
I like it.
So I cannot compare.
All right. No, I just, it's honest question.
Simple
honest answer.
That, yeah.
You want another question? Perfect.
Okay, about the flexibility of the solution. What if you decide in some time to extend it, the Outpost? Just what are the options, maybe?
You can order additional. For example, if you need to extend your compute, yes, you order additional SKUs, and you get this physical server installed in the rack. Of course, if you go above some level, then you can also, so you can scale up. And you can scale it
horizontally, right?
Yes.
Thank you.
So if they are like running you the hardware in the rack, there is always the space to install additional hardware on top.
Okay, we have another question. Thank you, guys. 1 second. Just like a bumping questions. 1 moment.
Thank you very much for your presentation. It was very interesting. I have actually 3 questions, not one. First one, does your hold on? Does your current infrastructure satisfies all your requirements?
No.
Awesome.
That's why we are looking for
expected,
different options.
The second question, actually, I have already performed the similar POC, but with VMware, so I understand what does it mean to data rooms. But based on my experience, 2 data rooms means that you should have, and high availability requirements means that you can load only 1 data rooms. And second one should be in a hot backup. Is it the same for Outpost?
Yes.
So why it's...
Well, you must remember that Outposts, the workloads on the Outposts, if you have 2 racks, can communicate with each other, but the Outposts are kind of a standalone unit in the AWS. So, okay, now AWS is doing something to have like out of the box high availability between a dimension multi-AZ for RDS, for example, yeah. But in the they started with no such thing. So you had to compensate with your with the way how you build your application and with your, so you deploy one EC2 machine on one outpost, second EC2 on the second outpost, and you either build a kind of a cluster on this EC2 instances, or your application that is deployed on EC2 has some kind of high availability mechanism implemented. But Outpost itself, it's not like you can migrate the workload from one outpost to another. No.
Mm-hmm.
No vMotion.
No, yeah, no vMotion.
I see. And no stretch clusters. Okay. And the latest one, probably also very short. Your current application, you mentioned it's a legacy code. For me, first of all, it looks like you just need to migrate, lift and shift from one virtual machine to another virtual machine. But you mentioned that it's not pretty easy for your current implementation. Why?
Could you rephrase the question?
Sure. You mentioned that currently you have a legacy code, and you need to migrate your legacy code from legacy application from your current data center to Outpost. It was your main goal for this POC.
Okay, maybe I will answer partially, then Miłoszz will jump. To just lift and shift the application was like no big deal. Yeah, it was like pretty straightforward.
Sure.
To fulfill the requirements of the high availability or like cluster solution, that was the issue. Yeah. So simply like move the application from our on-premise to Outpost and deploy it on the virtual machine as it's already like running on the virtual machine. There is like not a really complex solution. You can even migrate in somehow. Yeah, but install it standard way, automated way using infrastructure as a code. So have some improvements about the future deployments, no issue. But the issue started when we tried to like replicate the similar solution we had in place in our classic 2 server room setup.
I see. Thank you very much.
Yeah, thank you. Any other questions? One here. All right. So he's closer.
I have a more philosophical question. So usually when you buy equipment and you want to build your own server room and on-premise, you usually invest the money for like 5 years. So Outpost is charged monthly, as far as I remember. So did you do a comparison of total cost of the ownership, including people, including engineers' work? Because in Outpost case, it would be probably a bit lower because it's easier to use. In typical like building your own data center, it would probably be a bit higher, but you do not pay for rent, so you invest the capex on buying the equipment. But so did you calculate it all over? How much will it cost to keep up with the Outpost and to buy your own hardware, to buy, I don't know, to run Kubernetes on top of it, to run something else, to run the VMs and so on and so forth?
I can answer partially, maybe Łukasz can add something. So we calculate the cost of the Outpost. Everything else was already there. So we had the like server room, air conditioning systems, cooling systems, electricity, everything there. So we didn't have to invest. But if you would like to start from scratch, you have like you start up and you would like to have some Outposts installed on site because you need to you have also startup related to the production systems, and you would like to have it in place, you also need to calculate this cost on top of Outpost. But simply speaking about Outpost, yes, it's switching from the CapEx to OpEx. So for some company, like loan perspective, you also need to switch your mindset and the way how you're like dealing with costs. It's the similar when we are switching from on-premise to public cloud, yes?
Yeah, but that wasn't my question. My question is it really worth it? I mean, is it cheaper to rent Outposts, or is it cheaper to buy equipment and run it on your own?
No, we didn't calculate that during the POC, within the POC, no.
Okay, thanks.
Thank you. Okay, so the last question, the final round. Right. You had a question, yeah? All right.
Regarding network requirements, you said that there is need to have the particular speed for the internet connectivity to allow this, but do you know how it works with the direct connect? I mean, is there any way to run this management backbone through the direct connect?
Actually, this is one of the options you have. So
Okay.
you either are using direct connect or VPC or other types of connection, but these two are like standard ones.
So,
Yes?
so you can have some kind of redundancy there.
In our case, in our factories, we are using SD-WAN so we have one connection on the internet links, yes, and our direct connection that we are utilizing is located in Switzerland. So the traffic from Outpost was going through the to the SD-WAN through the internet link, but through the SD-WAN to our mesh to the PMI mesh, and it was entering the data center, and from there it was going through the direct connect to AWS.
Yeah, but this was in our case.
So-
If you would like to set up for your purposes, you can use
Yes.
whatever.
But it was for your VPC connection, or also for this management layer. I mean, when you are managing VMs from the hyperscaler console, it will also go this way.
For both. And
Okay.
Yes, for both. You must remember that there is a local connection, that Outpost is connected to the local network and to the other Outpost, for example, when you have workloads, and there is this service link that is used for this management plane. Yes, basically,
Yeah,
for communication with the
we
management.
didn't decide to install another direct connect because we already had one in place. So it was like simple to reuse it and install additional one just for POC.
One more quick one. You said that you need to define the VM size upfront to, let's say, fit into the hardware you ordered.
Okay.
Is there also, or did you observe the same limitations? I mean, when you, for example, spin up small VM, then you have slower network and smaller throughput for the disk.
Yes.
Is the same here?
Yes,
Okay.
all the limitations that come from the instance size are also applied on the Outposts. So you can't have 10 gigabit connectivity for tiny for M5 tiny. There is one like that. Okay, for large even. You need to have, well, it was a very good point for our SQL farm, because our SQL farm we deployed a single instance on the Outpost, on a single Outpost. That was M5 12X large, so it was pretty big. But it was, as I mentioned, it was supposed to be used as a shared farm. So we had multiple Microsoft SQL Server instances installed on it. And in this case, we had this 10 gigabit connectivity that we wanted to have. But in fact, when we had the VPC, the connection between the VPCs, we were capped at the 5.
Okay, there are any questions? Yeah, there are one. So
Can we finish?
Yeah. No, that's just one. So you said that there was no problems with hardware. Let's say that hardware problem was in the end. But my question is, if the AWS support is proactive support or reactive support regarding failure of the hardware. So they measure some kind of, like smart for disks or pre.
I don't know.
Okay.
This disk failure was kind of also surprising for us, because one day the guy came and said, you have a problem in your rack. Okay, please fix it.
Okay.
So I don't know.
So final question
predictive
for you?
failure or
just curious. He came like literally. He came to the factory, or
yes,
he called you.
Yes.
Interesting how it's organized. So like, luckily you were in office. You walk him through the rack room, right?
Yeah, but they contacted us. I received an email. Yeah, but it was kind of like, and it wasn't. He visited us the next day. Yeah.
Okay, yeah. Amazing. So he's in Krakow probably, right?
No, he's located in Warsaw.
Anyway, 3 hours, right?
Yeah.
Thanks.
Cool. Thank you very much, guys. As always, a lot of questions. Hey, give us a shout for guys. Woo! Thank you very much.
Finally.
So right now you can go and grab a beer. Good. And Łukaszz will enter to the stage. I think we will talk a little bit about containers again. Ah, shit, man. All the time containers. You should talk about lambdas or something, only containers. Next time. So there is a thing. The people who will ask the most questions will get surprises here. And also people online will get some vouchers. So go for it, guys. Go for it.
Yeah, still vouchers
are there. The beer is, like a queue for a beer is going to be marvelous. Łukaszz, are you ready? Yeah, of course. No, because you need to connect yourself. This is the worst one. Everything's supposed to be wireless right now. 5 minutes, okay?
Yeah.
We'll take a short break, 5 minutes, because everybody's thirsty after so many questions. And yeah.
No, to jest najbardziej przerażające. Tak. Nie,
I teraz się go pytam, jak to będzie? No, tak jak
ogólnie tak. Wyciszasz się, nie ma kamery. No tak jest. Ty dajesz szef. Ale nie zobaczymy to zadziała? Tak. Ja będę patrzył. No i pewnie już to właśnie dokładnie. Jest okej.
Hey, let's have a short conversation. Sit down on casting couch.
Oh, okay.
Yeah, I just move my, gifts a little bit.
Sure.
All right. Your first presentation. You was in AWS User Group here.
Yeah, sure. First after COVID, for sure.
First after COVID, yeah. And it's right now you are at the vendor side, I understand.
Exactly. I represent vendor today.
Very nice. Very nice. You see, guys,
big
good, like a career jump. One time here, going to AWS. It's like a straightforward. It's like a highway from here. We slowly will be starting. Maria, could you push a little bit, guys, there, if it's possible, or Kasia, to bring people, because they just occupating a bar. It's always this problem, the problem of alcoholism. It's in IT, it's huge. I don't know if you realize that on the big conference, so much alcohol, that I think that after 2-3 days, this is like high functioning alcoholics, only. It's just like unbelievable.
It's the risk of conference.
It's the risk of conference that we will proudly take. Exactly. So who is going right now for a big event? Like been somebody on KubeCon last week? Oh, you've been on KubeCon. No, you don't been on KubeCon. Come on the stage. I'm just kidding, man. Don't worry. All right. So high functioning alcoholics here. Very good. It's not about you guys. No, it's about those guys that are in behind. So we will start slowly. Okay. Go for it, and I will just take out the people from their comfort zone. Okay. All right. Let's start.
Okay.
Again, containers.
Again, containers. Yeah.
And man, it's again containers all the time. Łukasz, thank you very much. The stage is yours.
Everyone loves containers. I don't know why Lambda is better, but let's talk about containers. So welcome everyone, especially new faces, as well as a couple of old friends from before COVID era. As I said, this is first hybrid speech I gave after COVID, so it's I'm very, very happy that we are back on track, and that we are back and we can meet in place at this place in person. So today I'm going to talk about ECS. The topic is not very popular. Everyone loves Kubernetes and everyone talks about Kubernetes. So I decided to do opposite. But let's first introduce myself. So my name is Łukasz. Currently, I work, as you could read, at AWS in Process department. So actually, we are consultants that we are helping the biggest customers with their cloud journey. For example, currently I work on the project where we migrate 15,000 servers to the cloud for one of the customer. So it's biggest migration project in EMEA right now. So it's quite interesting and quite challenging work. After hours, I help developers and DevOps engineers to accelerate their careers to the public cloud. I am online course creator. I've got a website called Kursy Cloud where you can find 2 courses, one on Terraform and one on developing on AWS. And the third one is coming soon. And I also run a YouTube channel, which URL you can see on the slide. You will find a lot of videos about AWS as well as some of the interviewing tips on the technical side. So if you are going to apply to AWS, I highly recommend watching this first. And I am big Kubernetes fan, but from my experience, not always this is a good case. For most of the customers, ECS is actually a better option, but as it's not widely known, so it's not widely popular. And I will try to change that today. So we will be talking about Elastic Container Service. Who have heard about that service before? Okay, who is using that? Okay, who is using Kubernetes? Okay, who is know what the container is? Okay. Okay, let's start with some basics on ECS. So ECS is a proprietary AWS container orchestration platform. It's similar to Kubernetes and have a similar feature set. You can have the same use cases in ECS as well as Kubernetes. However, it's much simpler than Kubernetes. This is both advantage as well as disadvantage, because you can get very, very quickly with your container journey on the cloud. But on the other hand, it's not as elastic as Kubernetes, because from my point of view, Kubernetes is not only the orchestrator platform, but also application developer platform. If you are getting very, very deep into Kubernetes, you will start creating applications that are using custom resources, that are using operators. And I think this is the case for Kubernetes, and this is where Kubernetes shines. However, Kubernetes is hard. It's not only hard to learn, but also hard to operate and do it efficiently. You also, as a developer, have to switch your mindset to design the apps that can integrate with that Kubernetes and leverage the features that it offers. ECS, on the other hand, is much simpler solution. You can get very, very quickly on board. You can actually do most of your projects with it, and I think you won't miss advanced feature very, very soon. One of the main selling point, but not the most important one is free control plane. If you are using Kubernetes service in AWS or any other cloud provider for production, you will have to pay for your control plane. That's not the case with ECS. It's completely free. You are only paying for hosting services like EC2 or containers, which I will talk in a minute. It's also well integrated with AWS resources. And by that, I mean, you don't have to invent monitoring. You don't have to reinvent any kind of logging solutions, centralized logging solution. You don't have to care how to integrate that with load balancer or any other AWS service. It integrates very, very well with AWS services. And we've got a couple of workloads that we can run on ECS. So actually, we can run a single run containers. For example, if you need to do some administrative job, or maybe you are running some batches on your cluster, you can run it as a single run. And then you also have a service capability. A service is similar to a deployment in Kubernetes. And service is a way to run a long-running service. And by service, and I will describe the service in details later. And the third option is actually integrating with CloudWatch events or Event Bridge right now. And you can run your containers on schedule. So, for example, you can run a container that will back up your solution or do something else. So this is quite nice. And as you can see, the coverage of main features with Kubernetes is quite good at that stage. To be able to understand what we will be doing in the demo in a minute, I will introduce some of the basic terms that we use when we are talking about ECS. They are not maybe very well defined. However, there's something like task definition. And by task definition, we mean a template. This is a kind of configuration that we will be using to hosting our services. So when you are starting your journey with ECS, after creating the cluster, you need to work on task definition. And inside that task definition, you define your containers. And by that, I mean image. By that, I mean variables, as well as resources that your container will use. You can also define things like mounting endpoints for your application or anything else that you will need. I will show that in the demo, what exactly can you define there. Then we have a task. Task is created using task definition. We are taking that template and creating a new instance. And this is a basic unit of work in ECS. Everything that you run on your cluster is a task. Task is similar to pod in Kubernetes. So if you are familiar with Kubernetes, you can easily map almost one-to-one with the task. Task group containers adds more configuration, for example, where that thing should run. So this is an extension and instance of the task definition. Then we have a cluster. Cluster, as I said, is as this is a fully managed service. You don't have to provision a control plane. You don't have to pay for that. So in ECS, cluster is just basically a unit of grouping for instances, for services, as well as unit for management. You can create as many clusters as you want, of course, within the quota. But this is not the task that is so heavy like provisioning a Kubernetes cluster. It is just clicking and creating that kind of logical cluster. And then we have a service. A service keeps track of running tasks. And so, for example, if I say to my service that I want to have 10 instances of my task, then it will keep track of that task. If one task fails, it recovers that and runs it again. And also, there is the possibility to auto-scale tasks within the service. And finally, we have two terms related to how we are actually running and hosting that service. So there is an ECS instance. And by that, in ECS terms, we mean EC2 instance running a task. So this is a virtual machine that you provision, you manage, and you can run tasks on that virtual machine. And there is also a second way, which is AWS Fargate. And Fargate is a serverless way to run tasks. I will talk about it within the next slides. So first, we've got a quite typical way to host your task, to host your containers. Basically, EC2 instances are based on EC2. So we are starting the virtual machine, and then we are installing agent for ECS. And when the agent is running, we can run a task from the ECS console. As with all EC2 instances, we are paying only for hours of running EC2 instances. So you can optimize your cost in very, very good way and to big extent, I can say, because you can choose the instance types, you can choose all the things related to savings plans, and you also can use spot instances if you need to save even more. So with ECS, it's quite nice and quite easy to run that cluster on spot instances and save 70% of the costs. When you are using ECS with EC2 class instances, your scaling item is actually auto-scaling group. So if there are lack of resources, you can use auto-scaling group to automatically add more virtual machines. And then you can also use the second part of auto-scaling, which is related to service. So actually, we've got 2 layers of scaling, which is quite tricky, but maybe later on that. And EC2 instances are a good choice for many small tasks. If you got, for example, microservices written in Golang that only weighs a couple of dozen megabytes, this is probably a good choice because you will save a lot when your services are very small. For example, with Java applications or other applications that use a lot of resources, the profit of running on EC2 is, I think, much smaller than from very, very small tasks. Then we have a second way to run the tasks, which is AWS Fargate. And AWS Fargate is a service that allows you to run containers without managing any underlying infrastructure. And AWS Fargate you can use with both ECS as well as Kubernetes on AWS. It doesn't matter which orchestrator you use. And in this way of running, you pay for hours of running each task. So actually, we got rid of all instances. AWS manages all the nodes for us, underlying nodes. We don't have any visibility on where it's running. We are just considering each task, and this is our unit of management. And we are paying for every hour of running that tasks. And why it's important? It's important because the smallest unit for Fargate is half a gigabyte of memory. So for example, if your service, as I said, uses very, very low footprint of memory, probably it doesn't make sense to run it in the Fargate model, especially if you've got, dozens of that microservices. In AWS Fargate, we've got only one layer of scaling. We don't care about underlying nodes and about underlying compute power. We are only caring about scaling our tasks. So actually, if you set the scaling, for instance, for your service, and this is the only thing you need. If your service is, underperforming, you just scale the service and that's all. You don't have to set auto-scaling groups or anything else. You don't have to manage any nodes, so there is no patching, there is no, provisioning any virtual machines, dealing with compliance of that virtual machine. So it is very, very straightforward to use AWS Fargate. And there is also a possibility to use a spot pricing model. I haven't explained what is the spot pricing model. Actually, spot pricing model is a model where you can say, AWS, you've got some spare capacity, because no one wants that server, so I will take that server on the reduced rate. But there is a downside. You will get 2-minute notice when someone needs that server for you. So actually using the spot instance on spot pricing model is using a spare capacity of AWS, but with the possibility of interruption. For stateless services, it's a great model because, as I said, you can save up to 70% of the cost of compute power, but your service needs to be serverless and stateless. I mean, you can also, for stateful services, handle all the cases, but you need to handle how to gracefully shut down the service. And I prepared 2 typical scenarios, and we will demo the first one of it. But there are typical scenarios with EC2 expect other than batches. So first one is hosting web app, and typical scenario includes multiple tasks that are running within ECS service. Then we have application load balancer, which is providing high availability for our incoming requests as well as load balancing the requests. And usually in that scenario, we also use a CloudFront, which is a CDN that we use to accelerate serving of the content. It can cache your static content. It can speed up the responses for your application. And the second scenario typically used within ECS is hosting API. In that case, we are getting rid of load balancer, and we are using a service called CloudMap. CloudMap is a service discovery tool that we are also using when we need to communicate between microservices. But we can also use it in the company of API Gateway, which is an entry point for our infrastructure. And today I will demo the first one, and we will deploy a simple Nginx application in 2 ways. I will show you how fast you can do it, but I will also show you a step-by-step process. So let me switch to the demo. Let me duplicate the screen and make sure that StreamYard is also working right now. Okay, this is the one, and then I think we need to switch the screen. So give me a minute, and we are back. Okay, so I'm in AWS console right now. Maybe let's start with the main view. So in AWS console, if you want to work with ECS, just type ECS in the search field. And then there is Elastic Container Service. Can you see it, or maybe make it a little bigger? Oh, that big. 120, okay. Ah, maybe that's right. So you've got a nice animation, which I won't play because I will describe everything by myself. And then on the left side, you've got a couple of sections. The first one is for Amazon ECS. You can see that we've got a couple of features here. We've got clusters and task definition. Let's maybe start with a task definition. Let's maybe start with the clusters. Yeah. The simplest way to get running with ECS is just clicking by Get Started. And here you've got a very, very quick image that describes every aspect of ECS. So we are starting with container definition, which is contained within the task definition. And by using task definition, we are creating a service, and the service is within a cluster. If you want to start, for example, simple Nginx service, you can select one of the templates here. You can also run a custom one, where you can specify your own image. But as I said, we will deploy Nginx today. So I'm selecting Nginx. Here you can put some of the settings. For example, task definition name. I can set networking modes and a couple of other things. Then I click to next. I can automatically provision a load balancer for my application. And then when I click next, I just need to put the name of the cluster, click on the next, and it's ready. It's creating my cluster. As you can see, within 2 or 3 minutes, I am able to run a very simple cluster. So thank you. That was my session. Just joking.
Hey, man. Hey, the time doesn't... Hey, no.
Just joking.
Cool.
I will describe what is happening here because there is a lot of magic.
Yeah, I was going to, because, I knew that you want to run away before. We had a guy last time, from AWS also, Raf. And he got, it doesn't work out. We will see how it's going to be because if it's going to it's not going to work out again, then it's going to be tricky, Nobody will believe that anything works there.
I was on the security conference one time, and one guy got angry on the organizers for hotel or something like that. And he literally finished all the session within 5 minutes. He goes straight to the conclusion about the security, vulnerability he found, and that was all. Everyone was surprised, especially the people that were late.
Yeah.
So what is happening here? So we are creating a couple of things. As you can see, we have our VPC created. It created 2 subnets for us. It created a security group. And it's pending on the cluster creation as well as load balancer. As it's provisioning, we will get into the task definition that was created for us, because there are a couple of interesting things here. Every task definition has revisions. As you can see, revision is put here under the column. And when you need to, for example, update your container by introducing new variables or just deploy the new version of the Docker image, you need to create a new revision. And these are read-only. You cannot mutate that revision, which is kind of tricky if you want to use things like Terraform, because you cannot actually modify that, and you need to create that every time. Terraform has a lot of issues with actually working with task revisions. Usually, I just ignore that task revision within my Terraform configuration and then use a CI/CD pipeline in order to be able to deploy that. Of course, it has all these advantages of full manifest as a code. And this is the same as with Kubernetes. If you want to, for example, approach our infrastructure in a versioned manner, we need to somehow version that task revisions. And, if we want to deploy that, there is an issue that we need to update that definition, and which is not matching our version control. But maybe more on that later. So what we have here, we have a basic JSON. We can provision our task definition as a simple JSON if we don't want to click. There are many, many options here. I mean, a lot of options. Most of the interesting ones are container definitions, where we actually map our image here. I will scroll down. Here's our image. As you can see, here we specify our image Nginx latest. But you can see all other options. For example, we can reserve some memory. We can reserve some CPU here, as well as we can specify environment variables. Of course, if you don't like JSON, if you don't like the code, you can go to the builder and actually let's create a new revision. Let's say I want to update something, maybe add some environment variable. So when I'm creating a new revision, I have ability to specify a task role. In ECS, you can give all tasks some kind of identity. And by that, I mean you can create a role that the task will use. And it's great because you don't have to provide the credentials on your own to the container. You can just specify the role and the proper permissions for the role, and then you can integrate easily with AWS services. There are a couple of ways for network mode. I'm not going to dig into that. And then we can set a couple of things. We can set that this task is able to run on EC2, Fargate, and external. What is external? If you have on-premise infrastructure, you can also plug it into ECS and actually manage your containers on-premise. So you don't have to have Outpost. You can just install it. Yeah, I know that this is shocking, but but calm down. So you can install the agent on your instance on-premise and authenticate with that, and then you can just provision your containers on-premise by using a control plane, which is in the cloud and which is free. Unfortunately, you have to pay for that integration, but that's the different story. ECS supports both Linux as well as Windows servers. So if you have Windows containers, you can run it as well, so which is also great. And then we are going to the details of the tasks. So first, you can request some kind of a memory. And as I said, you are able to provision at least half a gigabyte of RAM. And in ECS Fargate, you are paying both on the memory that you are allocating, as well as the CPU you are allocating. So you can, for example, allocate one CPU, and then I need to put 2 gigabytes of memory in order to be able to provision that. Then you have a container definitions and these nice 2 bars. What are they are saying? They are saying that we are using only 1/4 of our allocated memory. The memory I allocated here is for the task. Under the hood, when you use AWS Fargate, it provisions a very, very small virtual machine, actually, that is based on the Nitro. And then within that virtual machine, it runs as your task. But you can have multiple containers here. So, for example, if you need some kind of, I don't know, Istio or service mesh or some kind of sidecar, you can add it as well here. And this way, you can share your memory between the containers in your tasks. If you want to add a container, you have such features available here. Of course, you can specify image as well as memory limits. This is all I already talked about. You can also specify port mappings, which is nice, health check commands, as well as some environment. And when we are talking about environment, it's really, really nice that you have a possibility not only to add a static value to your environment variables, but also integrate it with other AWS services. If you select a value from here, you can integrate your task, for example, with secrets manager. So you don't have to care about how to store the secret because AWS solves that problem for you. You just provision your service in a secret manager, and you can just reference it here. So this is very, very nice, especially if you've got multiple microservices that needs to share some of the secrets. If you think that secrets manager is too costly, too expensive, you can use also parameter store for that. Okay, then we have a couple of conditions here. For example, ECS allows you to do the things like start containers as well as complete containers, which is similar to the lifecycle containers in Kubernetes. So as you can see, it has quite advanced features as well. Then we have timeouts, network settings. I think I will skip that and go directly to more important things. If you have a stateful service, you can map a volume to it. And the nice thing here is that you can not only mount the local volume, for example, for EC2 instance, but if you've got EFS, which is an NFS managed service, you can mount a volume from EFS right here to the ECS tasks. So you can save your data on the shared network storage, which is pretty nice. The same applies with log configuration. I mean, you don't have to reinvent the wheel. ECS have you covered. You can easily integrate with CloudWatch logs. You just specify the group name, region, as well as the stream, and all the logs from your containers will land just here. Of course, if you've got multiple containers within one task, you can divide that to the separate groups or separate streams, which gives you a lot of flexibility when it comes to managing logs. And then we have things like resource limit, which I will skip right now. Yeah. There are a couple of integrations here, app mesh if you are using service mesh as well as proxy. I won't talk about that in details today. Sorry, this is introductory. Okay, we can create a new revision and that revision is set. Let's go back to my cluster. As you can see, it has been provisioned. And what we have here, let's inspect that. So first we've got a cluster, which, as I said, is a way of grouping your tasks, your services, and your instances. And what we have here, maybe I will hide that. We have a general summary here, as well as the list of the tasks and services that we have on our cluster. As you can see, I've got a single service right now, which is in the status active, and by that I mean it's running. Its service type is replica, so actually I want to run multiple replica. The other one is running task on each host. So for example, if you've got things like antivirus software or maybe some security stuff, you can run it in the mode that it deploys to every node in the cluster. It doesn't apply to the Fargate, but you have a possibility right here. If I want to scale that service, I can just click update and then put the name, the number of tasks I want to run on my Fargate. Just next, next, and next, and update the service. And now my cluster is scaling. Within a minute or two, I will have all my containers provisioned. We can observe that here. You will see that it's provisioning and running. So it's very, very easy, your cluster. And because we are running on the Fargate mode, I don't have to care about capacity of my servers. I can scale as big as I need for a moment. If you connect that to CloudWatch logs and create some kind of auto-scaling policies, your application can adjust to the workload that you need at very, very specific moment. So this is very, very powerful and very, very nice that this is so easy. If we are on the service level, we can dive deep into the specific task. For example, I want to see what's happening within that task. And I have a couple of things here. A basic summary on my task, when I created it, when it started, things like IP addressing. Interesting part, you can run ECS task with public IPs. So if you've got a very, very simple services or maybe something that should be exposed publicly, you can do it very, very easy. This is also the way to save the cost, for example, for developer cluster. If you don't want to provision, all the stuff related to NAT gateways, to load balancers, and other stuff, and you only need, for example, single instance of the container, you can use that. Then we have details of our containers. This is basically the same as I showed you before. And the interesting part starts here. When I click on the logs tab, I've got logs from this specific tasks here. So this is integrated with CloudWatch logs. I don't have to go to the separate console, to CloudWatch and then search for the proper log group. I can just log on the specific task on the logs tab, and then I have all my logs in place. So this is really, really handy. Okay, let's go back to my service level. At the service level, we have some metrics. For example, we can see how our application is performing in terms of CPU utilization as well as memory utilization. So this is actually a data aggregated over all the containers that are within our service. So you can see minimum, maximum, and average measures. So this is also very, very nice. As you can see on the service level, we also have a log tabs. So actually what it shows us, it shows all the logs from all our tasks within that service combined. So if you want to, for example, trace multiple requests, you can easily do that by using the logs on the service console. This is quite nice. Then we have auto-scaling. Maybe I will show that later. And then we have a tab with events when we can see what's happening under the hood. So here you can troubleshoot all the issues. For example, if your container is failing, you will see that, for example, that container was failed and restarted, and you can inspect that specific instance. As you can see, also you have some events related to load balancer, and that the service were registered within a load balancer. And also, as I said, you can see all the tasks that belongs to that specific service. If you need to restart the task, it's also very, very easy. You can just click on the stop and the task is restarted. So it's very, very easy. Okay, let's go back and see what's running on my cluster. So not only I provisioned cluster and the service and also log group, as I showed you, we have also a load balancer here. We are automatically redirected to EC2 console to see the load balancers I have provisioned, and we are filtered out to the load balancer related to our service. So as you can see, ECS creator created a load balancer for me. It has a basic configuration of the listener as well as some target group. When we go here to the target group level, we can inspect that actually there is some kind of service, some kind of instances registered to that target group. Here you can see the details. So here you can see that we've got multiple healthy instances of our task. This is really, really handy, you know, to not only be able to monitor on the cluster level, but also for actual traffic level. Of course, as we've got managed load balancer here that exports some logs, we can use that for auto-scaling. So this is very, very powerful because in most cases, in most simple cases, you can base your scaling on, for example, CPU usage, which is fine for applications written, for example, in PHP. But for other applications, this is not a good metric because, you know, you may run out of memory or something like that. And you are unable to serve the application, but CPU may be fine. So you can, for example, use as a metrics from ALB, like number of requests or latency or any other metrics that is exposed by the load balancer, and use that metrics to actually scale your infrastructure behind the scene. So this is really, really, really powerful. What else do we have? We've got a security group. Each task has its own elastic network interface. So it has IP address and also it gets a security group. So you can limit your traffic to each task by defining a security group. So which is very, very similar to what you do on EC2 instances. So this is quite powerful thing because, as I said, not only you can set the role and limit the permissions of your task, but also set the security group. And by doing that, you basically have the same functionality as a virtual machine. I mean, you've got a role, you've got some computing power, so you've got memory, you've got ability to mount a disk, but you don't have any burden related to managing that instance. So it's quite beautiful, and that's one of the reasons I really prefer ECS over Kubernetes, because, you know, in the long run you don't have to manage anything. You just set the infrastructure once and you can forget about it, because if you configure it correctly, you don't have to care about, you know, updates or any other stuff that is going under the hood. Okay, let's go back to my main thing. So that was the very, very quick way to create the cluster. You can also do it step by step. And now I will show you the other way, the hard part. which is not that hard. If you want to customize all the settings for your cluster, or maybe you need some kind of custom configuration, you can go with creating a cluster using that creator. Here you can select between 3 modes. I mean EC2 on Linux as well as EC2 on Windows, or networking only, which is used especially for AWS Fargate. And in this model, you can also mix, of course, with the Fargate. So there is a possibility, for example, that you provision some of the basic infrastructure using EC2. And if you run out of capacity, there is a possibility, that you configure a fallback and that will go to AWS Fargate. It's kind of advanced configuration, but it's totally possible. Okay, I will select that one. Let's say it's a hard way. Let's say I want to create a new VPC and just create. And there my cluster is provisioning. Of course, I highly recommend that you do all that stuff using infrastructure as a code, because it's easier to maintain in the long run. And ECS is quite nice to provision in the infrastructure as a code, especially if you've got multiple templates. For example, for one customer in my previous job, I deployed a dozen or a couple dozens of websites based on WordPress simply on ECS, and it was quite nice and quite nice experience, because I don't have to manage all the servers. Each instance was a totally separated resource. So I don't have to care that one customer and one website is impacting the performance of the other. So that was quite nice. And now we are waiting for CloudFormation stack to complete. This stack creates a VPC for me. So let's wait for it. And that's it. Now I have my cluster ready. And let's say I want to create another Nginx service. So I want to configure the service. I will be running it on a Fargate. This is Linux. I will reuse my container definition. I will set my cluster to hardware. I will start 2 tasks. Here you can also set some of the things related to deployment. And basically, you've got a percentage of healthy tasks that you need to have running all the time, and you also have ability to select between rolling update and blue-green deployment, which is really nice, because ECS can guarantee you that you won't break your service by deploying a new version. For example, if you deploy the faulty container that cannot start or has a wrong configuration or has anything wrong within itself, ECS can actually prevent you from, totally destroying your service. It will keep the old version, at least a couple of containers from old version, and then we will try to deploy the new version of the software. And you can use rolling update, which is basically replacing one by one each task with older version with the new version. Or you can go with blue-green deployment, which actually deploys the whole set of the new containers. And then if this is passing health checks, it switches all the traffic to the new group. So this is quite nice. And to be honest, it helped many developers in my previous companies, to destroying the whole service by provisioning some faulty applications. Then we can configure things like security groups, like subnets, etc. Here, as I'm going with the complex mode of configuration, I can set if I want to assign public IPs. Then I can select some kind of load balancer. As you can see, we have ability to use all types of load balancers. We will use ALB when we have web applications, but ECS is perfect solution when you have some kind of service that, for example, uses TCP connectivity. And this is also why I wanted to talk about ECS, not Lambda, because Lambda actually can handle only HTTP requests. If you have any application that requires you a different type of connectivity, but you don't want to go the server full way, as I can say, you can go serverless with Fargate and deploy your, for example, TCP application here. So it's quite easy, for example, to deploy, I don't know, RabbitMQ or any kind of MQs or databases or something, very custom. So you can just use network load balancer and then use it for load balancing TCP traffic. So this is, or UDP traffic, of course. But in my case, I will use the load balancer. Oh, I don't have any load balancers in that VPC. That doesn't matter for now because I'm using auto-assign public IP. So in that case, I will show you how it works with using that. As you can see, I can also use service discovery integration. This is a thing that we use when we want to deploy a serverless API on Fargate. So actually, I can register my container to the service discovery, and this way it becomes available for other AWS services like API Gateway. If you're using that kind of pattern, let me maybe go back to my presentation and go here for a moment. In that pattern, you can use, for example, API Gateway to securely connect to your service. This is better than ALB in that manner that in that case, we are not exposing anything to the internet. We are exposing only API Gateway, which does things like authentication, caching, and limitation of the request. And then we are integrating within an ECS service that is within our VPC, totally locked from outside the world. So this is quite nice pattern. And then go to next step. This time I will configure the auto scaling just to show you how easy it is. So we are specifying a number of tasks that we want in our auto scaling group. Let's say it's 1 to 3 with starting point of 2. And then we need to have some kind of scaling policy. As you can see, we've got a policy name, let's call it test. And we've got a couple of metrics here, predefined metrics. We can use average CPU utilization, memory utilization, or as I said, your request count per target. So actually, if we have ALB associated with our service, it's that easy. You can just select that metric and it automatically scale with the number of requests increasing for your workload. And then I can set that target value is, for example, 50%. And by that, I mean, if the service, I mean, it will scale up if the average CPU utilization is greater than 50%. And then you have some of the fine-tuning settings like cooldown periods. Okay, and now I'm creating a service. As you can see, under the hood, it's creating a lot of stuff. If you want to replicate all that stuff, for example, in Terraform, and there is a lot of code to write, but you can contact me. I've got a couple of templates I can send you. Yeah, because I spend a lot of time, fine-tuning that in Terraform. So I'm quite proud of that part of code. Oh, and you can also configure a deployment straight for code pipeline. That's also a benefit here. And as you can see, my service is running. I won't be able to make that utilization so big that I can show you how it scales in the real time, but you can believe me that it's working. Okay, and as you can see, we've got auto-scaling things here. Okay, and last thing probably in my presentation is I want to show you how to do deployments. So to do that, we will actually deploy a new version of our task to the cluster. We are doing that by clicking on the update service. And as you can see, we've got a couple of revisions for my task definition here. So let's see, I want to roll back to the previous version of the service because new version is using too much resources. I just clicked one here. And then I click next step, and next step because I don't want to change any other parameters. And now the service was updated and the magic happens behind the scene. What we have here, we've got a new deployment. You can see it here. It says that we want to have 2 new task definitions. currently we have 0 and 0 pending and 0 running. So what is happening here is that ECS tries to provision new services, and after it provisions a new services, it checks the health check of the container, then it checks the health check on the load balancer, and if both are green, then the target is okay, and we can see that this is a running state. And after we reach the same number as desired count, it will start to decrease the number of our own, our previous deployment, which is the previous one. So actually, we are doing rolling update here. What is important here, if you are not using a Fargate, I mean that serverless way to host the container, you need to take into account that you need some additional capacity on your EC2 instances to handle that additional task. Or maybe you can reconfigure the service that you want to kill one instance first and then replace that with the new version. As you can see, now we have running count equals 2, and that means we've got 2 containers of previous version and 2 containers of the new version. All that containers are running, are currently connected to the load balancer, and now ECS starts to destroy the previous version. You will see that in the minute. Yeah, right now, after I refreshed, we see that there is a 0 running count, and that means that ECS destroyed the previous version. And within a minute or 2, we will have just only 1 task. Yeah, and if we go to the details of the task, we see that we've got our task definition of 1, which is a new version which are updated. And we can also inspect that we've got 2 tasks that were stopped by ECS. So as you can see, we have all that things in place. So this is how easy it is to operate ECS. As I said, this is kind of service that you can fire and forget. And I think this is the best selling point for that service. For 99% of cases, I can say that it should be enough for you to use ECS. You don't have to care about EKS. And actually, that's all. Let's go to the questions.
Right. Questions?
Thanks a lot. Before the questions, just a quick reminder. So you still can get the credits from AWS if you just answer questions. That the link is on YouTube. So yeah, be aware that the credits are still there.
Okay, I have a question to you. Here. You said that a lot of benefits of using ECS. Can you explain or highlight some the biggest limitations between ECS and Kubernetes?
Okay, so from my experience, it's quite easy to use. Maybe let's put a slide here. I don't want to show my desktop. Sorry. Yeah. Maybe to the end. From my experience, the main disadvantage of ECS is when it comes to handling stateful application. Because ECS is perfect when you have stateless application. It is this case, but it lacks some of the primitives that are required for stateful applications. For example, if you want to host a MySQL database with replication, you cannot do that easily. I mean, Kubernetes provides you stateful set, which has IP addressing as well as host name naming that you can easily, for example, in the predictive way, know how to set up that using your scripts. In ECS, you are not able to provide such features. So actually, some of the stateful application can have troubles running on that. The second limitation is that in Kubernetes, you can use volumes, for example, for EBS, which are attached directly to the node and are more performant in terms of raw access to the disk. In ECS, you can mount an EFS volume, which is a shared file storage, but this is a file storage, so automatically you cannot use anything with raw I/O to the disk, but also it's less performant because on the overhead that NFS gives to you. That's the second part, and third limitation is probably with with lack of some advanced things like custom resources. I mean, in my previous job, when I worked on Pragmatic Coders, which is a software house, for many customers we developed on top of the custom resources, and it was quite nice because we were able to configure the application using custom resources. Here you cannot do that. You don't have any kind of abstract features that you can extend with ECS. So you cannot do multiple levels of abstraction on the application. This is simply a container orchestration, not a platform that you can build with the features, like custom resources. Anything else? Nope. I think these are the main limitations of ECS.
Okay.
Or maybe one more. You cannot run it on premises without the connectivity to AWS. So actually, there's no way to. I mean, you can run the agent and you can run a workload on premises, but the control plane is still on AWS. So if you need something that will run on premise or completely disconnected from AWS, that's not the case. I mean, the connectivity is needed, for example, for things like shipping logs, for scanning the containers. However, if you lose the connectivity, the containers are still running on their agent.
Okay, so do you recommend to use these separate services for different purposes, yes?
Yeah, for 95%, as I said, ECS is just enough. But if you have some special cases, like you want to integrate applications with underlying infrastructure and leverage that infrastructure, and your developers are aware how to use it, because this is a very important point, I think this is where Kubernetes should be considered.
Thank you.
Also, scenarios like multi-cloud or things like that is the case, yeah.
Online questions? Do you have online questions? No online questions.
No
on-site questions then. Okay.
Yes.
Please.
Thank you. So 2 questions actually. One about the customers. You mentioned that you work with many customers, and do you recall any success stories of migrating from EKS or Kubernetes, on-premise Kubernetes to ECS, or from anything else that, let's say, you convinced someone
actually,
to do
for the customer I worked with deploying the WordPress sites, we started with Kubernetes. We started with the normal EC2 instance, then migrated to Kubernetes, but it was too much to manage actually, and we decided that it will be most cost efficient and in terms both of the cost of the infrastructure as well as the management overhead to move that 40+ sites just to ECS. And also on Kubernetes, there was an issue that, of course, we set limits on CPU, etc. But if you've got multiple small services, like the site that is not using a lot of resources, that is sitting next to other sites that are highly in traffic, you can have a noisy neighbors problem. Performance of one container is impacting another application hosted on the same instance. And when we moved to ECS Fargate, it actually solved all our issues, because each and every container was totally isolated and decoupled from underlying infrastructure and underlying worker nodes.
Okay, thank you. And one more about the cost, because you mentioned the spot pricing model for Fargate, right? Mm-hmm. And I was wondering, because I like both ECS and Lambda, both are great for lazy people, but which one is more cost effective for like scheduled tasks which are running less than 2 minutes, so you are not in the risk that something will go down with the spot model, right? Do you know, or should I check?
It depends on the resources that you need.
Let's say the same level of resources, right?
Probably Lambda will be cheaper, but we can calculate that.
Okay.
However, if you compare Lambda with ECS, and for example, you have a running container, it will be cheaper from operating cost of view just to move your container to ECS. Yeah? Yes. Because Lambda, it supports containers right now. However, it requires you to have a handler in a specific format. So if you have any containers that are just running like that, you can simply move it to ECS without much effort.
Okay. Thank you very much.
ECS is also very good at batch processing. You can simply integrate what I didn't use that, but AWS Batch probably integrates with ECS as well. So you can use AWS Batch to process multiple requests.
So one question from me. What you showed us was a quite simple example, how it works on real projects. I mean, from the optimization perspective, the speed of working, are there better tools or?
What can I say? I mean, in Fargate model, you need to wait 2 or 3 minutes to roll out new versions. So it's quite a long time. If you compare that to Kubernetes and simply killing the pod and having an instant restart, it's quite a long. But you need, but you know, it needs to provision all the resources under the hood. So yeah, it's slower than iterating over, you know, kube control apply. But you should not use kube control apply. You should use some kind of pipeline. But strictly from the practical point of view speaking, yeah, deploying new versions is much slower here, especially on the Fargate, in comparison to Kubernetes. What was the first part of the question?
Yeah, generally from the project point of view, the optimization and time of working.
I strongly suggest for more customers to go with start with the Fargate model because it's much more easier to handle, and it's also cost efficient, especially if you use spot pricing. And then working on that, you can monitor all your services and see how much memory or CPU it's using, and then you can size, for example, instances and try to optimize it using EC2 instances. As I said, you can mix both models. You can create tasks in both groups, and then you can play with that. And but unfortunately, there is nothing I know that can automatically optimize that for you. I mean, you need to work that on the case-by-case basis and optimize by hand. AWS compute suggester does not support things like that, like comparing one to the other.
Thank you.
Any questions?
One more here.
There's a question.
Actually, three questions. First one. Sorry. First one, you mentioned service mesh, Istio, but it looks like I misunderstood it. Does it support?
You've got an app mesh service from AWS, which is kind of similar deployment,
I mean, from visibility perspective, from traffic management perspective, or just something similar, but not at all.
You just suggested a next session for me on app mesh. I mean, app mesh gives you some of the similar visibility like Istio. However, I need to deep dive on that because I haven't used that extensively. Only just a couple of demos out of curiosity.
Okay, I see. Next question about debugging. Is it possible to join a container to run something within this container?
Absolutely.
You haven't shown it.
Absolutely. Yeah, because you need to configure a couple of stuff on AWS CLI and install. However, it is possible to actually go into shell of the container. You are using the same approach that you are using with Session Manager. So the tooling is the same. You just need to enable that option on the container level. And then you are able to actually log in directly to the container and then inspect the contents of the container and everything what's inside.
Do I need to prepare this container for this case?
You need only to have some kind of shell there. So for example, you've got statically linked Golang binary, it won't work. But if you have any shell, you can easily.
And the latest one about efficiency, cost efficiency. Does Fargate support something like Knative when I can freeze my container if I don't have any workload and turn on it automatically, or just after scaling model?
Auto scaling model, yeah. I mean, there is no scaling.
Is it possible to scale into to zero without any workload?
Not using the automatic tools.
Okay.
Yeah, but because provisioning takes 2 or 3 minutes, so it's not practical to actually have container scaled to 0 and then wait 3 minutes for that.
Okay, thank you.
Right, just those 3 questions. I can't believe it, man. Only 3. Any other question?
I have a question. So,
you have a question? No, man. I need to give you my microphone.
Okay. So you were mentioning that it takes time to provision or scale. With EC2, you can do like predictive auto scaling. So basically, if I need the capacity a bit earlier than the traffic like reaches the CloudWatch or whatever, is it possible somehow to use the predictive auto scaling from EC2 with ECS?
When you are talking about hosting on EC2 instances, you've got that 2 layers of auto scaling. So first you are scaling the task itself, and then underlying infrastructure. And it's actually quite hard to predict how the underlying infrastructure should scale. So I don't think predictive auto scaling will work in that case. I mean, there are some hacks that you can, for example, provision some kind of dummy containers that are just filling the space but have lower priority to other containers just to, inflate the EC2 instances up front. But this is not that intelligent yet.
Okay, thanks. Okay, I have a question. You said that 3 minutes the entire infrastructure is spinning up.
From my observation, it's something like that.
And you can use spot instances to that?
Yeah. That's right.
And you will not lose this spot instance till the moment that it will spin up? Because it's like 45 seconds? It's guaranteed?
I mean, it depends on the couple of things. Size of the container is one of them.
Yeah.
The one is provision elastic network interface, which takes a while.
Yeah, exactly. So,
and then registering to cloud.
I don't remember now, because it was like 45 seconds or 60 seconds you had guarantee time of spot.
2 minutes.
2 minutes. So if you have 3 minutes, then you can finish up with ready infrastructure, but dead already. No, my question, because the times are just not fitting,
Interesting thing. I think I need to.
Okay, good.
And ask.
Good. Hard question on the end. Anybody else? Can I get this one? No, just kidding.
Yeah, sure. I haven't noticed such a situation.
All right, I'm just asking, because the minutes doesn't fit,
Yeah, and to be honest, I think you should not care about it because,
I will not care.
Get another instance.
It's a paid service at the end. Any questions?
That's the beauty.
All right.
Yeah, so.
Do you plan to improve ECS to have other features or improve current features?
I mean, ECS is constantly expanding and we are adding new features. For example, ability to enter to the container, it was not available, I don't know, a year or two. So there are new features coming to the service. And you also can enable, so you can also see that for example, you selecting the task, you are selecting the version of the platform itself. So at the moment it's 1.4 for Fargate. So if you in the future want to use some of the features, you need to bump that version of the cluster, which is quite easy. But yes, we are expanding the service, and if you have any ideas on how we should expand, you can share with our support. Or maybe with me, and I will put somewhere in the Salesforce. But there is a customer waiting for that feature.
Thank you. I will talk to my guys.
Sure.
Right. Thank you very much, guys. I think that's let's give a shout for Łukaszz. Yeah. Thank you, Łukaszz.
And subscribe to my channel.
Yeah, go for it. Kursy.cloud/YouTube.
I almost have 1,000 viewers, only 700 left.
All right. Yeah, we are here. The community is for building, for help with that. So thank you very much. I think we have 3 packages from our partner, Philip Morris. So the first one is going to this gentleman here because the most amount of questions. Yeah, cool. And another one, like you, I like what you said. It's easy for people, it's the easiest solution for lazy people. So you need to choose the way that you spend the less energy. So please, another one is here, because it's very close by. So thank you very much. Thank you for your for actions today. And the last one, it's for the 6th question person.
Yes.
Yeah, come on, man. Thank you. Thank you very much for that. And guys, for sure we will meet again. I don't know if before holidays, maybe after, but yeah, we have also the winners online. So Shimon, go for it.
Yeah. So the winners are for the vouchers. It's Anas dot Bakla. The next one is TF79, and the third one is 𝐶𝐞𝐥𝐻. So those people will receive vouchers for AWS credits.
It's a new level of
Congrats.
trolling having such.
No, man, come on. He could go worse, or she,
Yeah, I know.
I think if next time you can be online.
They just inspired me.
So thank you very much. Do you want to say something on the end? Perfect.
Yes, I also would like to thank you very much for your attention, for your time being here and listening our boring stories about Outpost, AKS, and other services. So thank you for the attention, and I hope you enjoy at least a bit.
Yeah, thank you very much. And guys, if you want to speak, if you want to be on the scene, please contact us over Meetup, okay, or on Twitter. And for sure, there's going to be a place to talk about the AWS solution, your experience, good and bad. Okay, so not that we need to say that only AWS is the best. Let's share experience. Yeah, thank you very much. And see you next time.
Thank you.